right now, a single second of an AI taking a breath before it speaks to you.
Just 1 second.
Yeah, just one single second. It actually represents hundreds of billions of dollars in server space, a frantic global arms race, and, well, a pretty massive looming safety crisis.
Oh, absolutely.
Because you pull out your phone, you ask it a question in a perfectly conversational tone, and a voice answers you back. And it pauses, it considers, it even uses filler words like, or well.
Right. It feels entirely human.
Exactly. But sustaining that 1 second of seamless audio is, it is essentially ripping the tech industry apart right now.
Yeah, the smoother and more natural the voice in your ear becomes, the more chaotic the machinery operating behind it actually is.
Totally. So welcome to today's deep dive. You are the essential third person in this conversation, and our mission today is to cut through all of that chaos.
There is a lot of it today.
There really is. Today is August 3, 2026, and we are unpacking a massive stack of updates from the Daily Tech Reader's AI News.
The goal here is basically to shortcut your path to being well-informed on the current state of the AI arms race.
Right. No information overload, just the critical insights. We're looking at the rapid evolution of voice AI, the frankly mind-boggling economics of global infrastructure, the rising dominance of open-source Chinese models, and finally,
A pretty sobering reality check on AI safety.
yeah, definitely sobering. Okay,
Yeah.
Let's unpack this, starting with the race to make AI sound indistinguishable from a human.
Right.
OpenAI just published a major engineering post today detailing their full duplex continuous voice architecture for GPT-5. And, the technical leaps they're describing here are wild.
They really are.
It's no longer just a text-to-speech engine reading a script.
Yeah.
The voice layer itself is actively delegating complex search and reasoning tasks to GPT 5.5 mid-conversation.
And doing it without ever breaking the social flow of the interaction, which is the crazy part.
Right.
The term full duplex is really the mechanical breakthrough here.
Really?
Well, in older systems, the architecture operated like a walkie-talkie. You speak, you wait for the system to process the text, and then the machine speaks back.
Over and out, basically.
Exactly. But full duplex implies bidirectional continuous audio streaming.
So it's listening while it's talking.
Yes. The model is listening, processing your interruptions, predicting when you might pause, and adjusting its tone, all while it is actively speaking to you.
Which is incredibly hard to do computationally.
It is. OpenAI achieved this by essentially decoupling the voice from the brain.
Okay, right.
The voice interface is a lightweight model designed purely to maintain the social rhythm and acoustic nuances of a human conversation.
The ums and ahs.
Right. While it does that, it is frantically pinging the massive GPT 5.5 foundation model in the background to run heavy logic, solve math, or fetch real-time web data.
I picture the architecture exactly like a late-night talk show host.
Oh, that's a good way to look at it.
Yeah, like the host sitting at the desk that is the voice layer is making perfect eye contact with the guest, who is you, the user.
Yeah.
The host is smiling, nodding, laughing at the right moments, keeping the conversation flowing flawlessly.
Right, doing all the social work.
Exactly. But meanwhile, they have an earpiece in, and their producer, which would be GPT 5.5, is screaming in their ear, handing them live research, fact-checking the guest, feeding them their next highly technical question.
And the host just absorbs all of that information without ever stuttering or breaking character. That captures the division of labor perfectly.
Yeah.
And, OpenAI is not the only company running a talk show right now.
Right. We saw the Microsoft leak.
Exactly. Over the weekend, a hidden entry in Microsoft's MAI playground revealed they are quietly testing a model called MAI Real-Time.
Which is their version of full duplex.
Yeah, a first-party, full duplex, bidirectional voice competitor. The documentation shows it already supports 17 languages natively, and it features 2 highly realistic voices they have named Victoria and Grant.
Wow. And then there's XAI too.
Right. Alongside Microsoft, XAI just released Grok Voice Think Fast 2.0. They're migrating it to their public API on August 5, which promises massive leaps in tool use reliability during live audio transcription.
So basically, everyone is rushing to own the voice layer because it's the ultimate user interface.
Absolutely. But this rush just collided with a massive legal wall.
Yes. The European Union AI Act's audio provenance rules, which officially took effect yesterday, August 2.
Yeah. What's fascinating here is how the regulation launched exactly simultaneously with these new capabilities. It makes voice AI the single most legally active frontier in the tech industry today.
It's all happening at once.
Exactly. In direct response to the EU mandate, OpenAI has officially integrated DeepMind's synthed audio watermarking into GPT-5, alongside new provenance detection APIs.
Okay, so if I can push back on this for a second,
Sure, go for it.
doesn't this entirely ruin the magic of the seamless human illusion we just talked about?
How do you mean?
Well, we are spending billions of dollars to engineer these systems to sound perfectly human, layering in synthetic breaths and pauses. But simultaneously, we're mandating a cryptographic barcode on every syllable to scream, "I am a robot." Isn't that a total paradox?
Well, yeah, but it is a deliberate paradox.
Okay.
The technology has crossed a critical threshold where human ears can no longer reliably detect the difference between synthetic and biological audio.
Which is terrifying.
Right. Without an embedded watermark, the potential for financial fraud, deepfake extortion, and social engineering at scale just becomes catastrophic.
No, for sure.
So SynthD solves this by modulating the audio waveform at a frequency human ears cannot perceive, but that a machine algorithm can instantly verify.
Ah, so we don't hear the barcode.
Exactly. The regulation forces a necessary compromise. The interaction feels entirely organic to the user, but the data itself remains mathematically verifiable to the network.
Right, well, that incredibly seamless full duplex talk show host we just described doesn't run on thin air.
Definitely not.
It demands an unfathomable amount of computing power, which leads directly into this massive industrial and economic shift happening behind the scenes.
The numbers are just crazy.
Yeah. OpenAI published a company manifesto on July 31, framing this era as the electrification of industry.
That's a bold claim.
Right. They argued that ultra-low-cost inference, which they claim is enabled by GPT 5.6, Sol's recent GPU kernel rewrites, is going to make frontier intelligence as ubiquitous as electricity.
Yeah, and just to clarify for everyone, the term inference refers to the actual running of the model to generate an answer.
Like when it's actively talking to you.
Right, as opposed to the initial training phase.
Mm-hmm.
And when OpenAI talks about kernel rewrites, they mean their engineers have rewritten the foundational software that instructs the graphics processing units, the GPUs, how to do basic math.
Just getting really deep into the code.
Exactly. By getting closer to the bare metal of the hardware, they can dramatically reduce the power consumption required for every single calculation.
Which adds up.
Big time. When you scale that efficiency across millions of daily users, it completely changes the unit economics of the technology, which, justifies the sheer scale of capital currently being deployed.
And speaking of capital, the numbers from the corporate earnings this week are staggering.
They're almost hard to comprehend.
Google Cloud revenues surged 82% to $24.8 billion. Alphabet also raised its full-year capital expenditure guidance to an incredible range of $195 billion to $205 billion.
That is just for infrastructure.
Right. And Microsoft Azure just crossed $100 billion in annual revenue, sending their stock up 5%.
And the momentum is carrying straight into Tuesday's upcoming earnings calls.
What are we expecting there?
Well, AMD is expecting $6.5 billion in data center revenue, heavily driven by shipments of their new MI350 AI chips and massive orders for Helios rack-scale systems.
Rack-scale.
Yeah. Palantir beat Q2 expectations entirely on the back of U.S. government AI contracts. And even SpaceX, reporting public earnings, is anticipating their internal AI revenue segment to jump to $2.2 billion.
Wow. You look at those figures and you realize the tech giants aren't just buying individual graphics cards anymore.
No, not at all. The macro transition here is about how computation is fundamentally built and sold.
Right.
A few years ago, a company might buy a few thousand GPUs and wire them together. Today, the bottleneck is not the speed of the individual chip.
What is it then?
It is the networking speed required for tens of thousands of chips to talk to each other simultaneously.
Oh, wow.
So companies are demanding full-stack, rack-scale infrastructure like the Helios systems AMD is shipping.
So they want the whole data center.
Basically, yeah. You are no longer buying a computer component. You are buying a massive, pre-networked mega brain that spans the size of a data center.
Okay, here's where it gets really interesting and where I have to challenge OpenAI's whole electrification analogy.
Okay, let's hear.
If AI is supposed to be like electricity cheap, abundant, flowing effortlessly into every home and business, why are prices actually going up?
That is the million-dollar question.
Right. Anthropic just announced they are ending their introductory pricing for Claude Sonnet 5 on August 34. The price is moving from $2 to $3 per million input tokens, and from $10 to $15 for output.
And the effective cost increase is actually much steeper than those list prices suggest.
Exactly, because their new tokenizer generates up to 35% more tokens for the exact same content.
Right.
If a tokenizer breaks words down into smaller, more granular pieces, a simple paragraph suddenly costs more units of compute to process, which invisibly jacks up the price for developers.
It's a hidden price hike.
Yeah. Plus, they're retiring Claude Opus 4.1 on August 5, essentially forcing users onto the newer, more expensive system.
Right.
So if Alphabet is spending $200 billion on infrastructure, isn't that like building a massive, incredibly expensive power grid before we even know if the everyday consumer can afford the electric bill?
That tension defines the trillion-dollar gamble happening in Silicon Valley right now.
It's a huge risk.
It is. The U.S. tech giants are pouring hundreds of billions into infrastructure to build an impenetrable economic moat.
A moat to keep everyone else out.
Exactly. The theory is that if you construct the biggest, most capital-intensive power grid on the planet, no startup or foreign competitor can possibly generate enough compute to challenge you.
But building that massive, expensive power grid creates an enormous pricing vulnerability.
How so?
Well, the U.S. tech giants assume sheer financial brute force is the only path to victory. But the global landscape is proving otherwise.
That's very true.
While the U.S. builds monolithic grids, other players are figuring out how to generate frontier-level power much more cheaply. The Daily Tech Reader noted that 6 of the top 10 most used models on OpenRouter recently came from Chinese companies, including Tencent, Minimax, DeepSeek, and Moonshot.
Yeah, we are in the middle of what researchers are calling the DeepSeek moment.
The DeepSeek moment.
Yeah, this is the industry-wide realization that highly capable frontier models can be engineered at much narrower cost margins. Instead of relying purely on brute force compute, these labs are using algorithmic efficiency, better data curation, and architectural tweaks to punch far above their weight class.
So working smarter, not harder.
Exactly. Moonshot's Kimi K3 launched on July 16th and is already matching U.S. frontier models like OpenAI's GPT 5.6, Solon Anthropic's Claude Fable 5 on complex coding and reasoning benchmarks.
That's incredible.
And DeepSeek is pushing the pace relentlessly. They're releasing their V4 Flash API in public beta early with their V4 Pro and an in-house coding tool called Harness pending mid-August.
It's just a nonstop wave.
It is. If we connect this to the bigger picture, this aggressive open source and international competition is entirely reshaping the pricing power of the U.S. giants.
Right.
You cannot maintain massive profit margins on a $200 billion data center investment if an agile international lab offers equivalent reasoning capabilities for a fraction of the cost.
It's like watching a massive, heavily armored freight train trying to race a fleet of stripped-down off-road vehicles.
That's exactly what it looks like.
The freight train. That $200 billion U.S. infrastructure is incredibly powerful, but its overhead is so massive it has to stay on a rigid track and charge high ticket prices just to maintain the engine.
All right.
While the off-road vehicles are agile, highly cost-efficient, and they are swarming the exact same destination for pennies on the dollar.
And the crazy thing is, those off-road vehicles aren't just international.
Right. Elon Musk at XAI is operating at a pace that breaks traditional software development cycles.
The cadence at XAI is practically unheard of for foundational models.
I mean, they just dropped Grok 4.5 in mid-July. Then Musk confirms Grok 4.6 is due in 2 weeks, and Grok 4.7 is coming 2 weeks after that.
It's wild.
They're shipping a new frontier model almost monthly.
And these are not lightweight iterations either. Not at all. Grok 4.5 is running on a 1.5 trillion parameter V9 foundation. To give you a sense of its capability, it scored 29.0% on the SWE Marathon benchmark, beating Claude Opus 4.8.
Wait, what exactly is the SWE Marathon?
The SWE Marathon tests autonomous software engineering. The AI is handed a complex GitHub issue, and it has to independently navigate the code base, write the patch, and test it without any human intervention.
Wow, so no hand-holding.
None. Scoring 29% means the model is successfully executing highly complex, multi-step autonomous reasoning.
So what does this all mean for the U.S. companies relying on those massive data centers? If Grok is shipping a new model every month and Chinese labs are dominating global usage charts by running leaner, is that $200 billion corporate infrastructure actually a massive vulnerability instead of an advantage?
It becomes a staggering vulnerability if the underlying architecture of AI shifts towards smaller, highly efficient models faster than the tech giants can recoup their initial hardware investments.
Which could definitely happen.
Alphabet is currently warning investors of a supply-constrained environment, even tapping third-party clouds as a bridge. But if XAI and Moonshot prove that you can achieve cutting-edge performance without owning a $100 billion Azure network, the entire economic thesis of the tech giants is completely destabilized.
That's a huge if.
And that immense financial pressure forces organizations to sprint. If you have to deploy a new frontier model every 2 weeks just to keep up with Moonshot and DeepSeek, you inevitably force your engineering teams to move faster than they should.
Which brings us to the most sobering part of the sources today, the reality check on AI safety.
Yeah, this part is pretty grim. The Future of Life Institute just released their Summer 2026 Safety Index.
What does that track?
It evaluates 9 major AI labs across dozens of different safety and governance indicators. And out of all 9 major labs, not a single one scored higher than a C+ fund.
Wow, not a single one. Anthropic topped the list with that C+ fund.
Yeah.
OpenAI and Google DeepMind received Cs. Meta got a D+ FEM.
Right.
And 3 labs failed outright.
Yeah.
XAI, DeepSeek, and Mistral all received S.
And the reviewers detailed exactly why those failing grades were issued.
It wasn't just a technicality.
No. They cited a noticeable pivot toward military AI applications, a broad corporate retreat from previous public safety commitments, and an outright refusal to undergo independent audits.
Refusing independent audits.
Yeah. When the companies pushing the technological frontier the fastest are refusing to let third-party safety auditors look at their model weights before deployment, it reveals the true cost of this arms race.
Speed over everything.
Exactly. Safety protocols are becoming a casualty of speed.
But the sources highlight an incredible paradox here. Because while safety scores are plummeting, these systems are simultaneously being used for miraculous applications.
Oh, the upside is massive.
DeepMind and Isomorphic Labs just expanded a massive biosecurity initiative. They are using multi-agent AI to conduct global pathogen surveillance, outbreak response, and rapid vaccine design, partnering directly with over 15 governments.
And Demis Hassabis at DeepMind is actively calling for an industry-funded international standards body.
Plus, DeepMind is also backing a $10 million multi-agent AI safety research call.
Furthermore, Anthropic's AI for Science grants just closed, offering $50,000 in Claude credits specifically designed to accelerate rare genetic disease research by mapping complex protein folds.
So they are doing good work.
They are. But this raises an important question regarding the deep contradiction defining the industry right now.
What's that?
Well, on one hand, we possess tools capable of unprecedented scientific acceleration, mapping global pathogens in real time, and designing therapeutics in days rather than years.
Right.
Yet, the institutions building these miraculous tools are actively retreating from their own safety promises and failing independent evaluations regarding how these models could be misused.
It feels exactly like a brilliant pharmaceutical company that has just discovered the cure for a dozen rare diseases, but absolutely refuses to let health inspectors look inside their factories.
That is a very apt comparison.
They are standing at the gate saying, "Look at these amazing vaccines we made," while actively locking the doors to the safety auditors. How are we supposed to trust these systems to monitor global pathogens when the companies building them are getting F grades for avoiding independent safety audits?
The tension you are describing is the defining characteristic of August 2026. The capabilities of the models are scaling exponentially, and the economic stakes are measured in the hundreds of billions of dollars. But the governance, the independent auditing, and the safety frameworks are demonstrably failing to keep pace with the engineering.
Because the market doesn't reward safety.
Precisely. The market is exclusively rewarding speed and capability, offering zero financial incentive for caution.
Which brings this whole deep dive full circle for you listening right now.
Yeah.
We started by looking at how natural and seamless it is to talk to a watermarked, full duplex GPT Live today. But to get that comforting voice in your ear, it required a $200 billion hardware boom, an all-out global war with agile open-source Chinese models undercutting U.S. tech, and an industry moving so fast that almost everyone is failing basic safety checks.
The sheer complexity operating invisibly behind the simple voice interface you use every day is staggering.
And that is why we do this deep dive for you, to shortcut your path to being well-informed. You get the critical aha moments, the underlying mechanics, and the broader context, without having to read through dozens of dense tech reports and corporate earnings statements.
We hope you walk away with a much clearer picture of the technological forces moving around you.
To wrap up, we want to leave you with a final thought to mull over on your own.
Okay.
If AI is truly the electrification of our era, and ultra-realistic voice AI is the new interface, What happens when the most natural, human-sounding voice whispering in your ear is powered by an invisible infrastructure so fiercely competitive and fast-moving that even its creators can't pass a safety inspection?
Thank you so much for joining us as we unpack the cutting edge of AI.
We'll catch you on the next deep dive. Keep questioning the tech around you.